Now we're at minus 130. Typically minus 132 dBm is what you can hear. And with the 1 dB loss, this thing does have excellent sensitivity. So we're minus 130, 31, 32, 33, 34, 35, 36.
I still hear it.
Minus 137 dBm. That thing is one hot receiver.
That's pretty good. How's it going, everybody? Thanks for clicking on the Ham Radio Crash Course. A couple of weeks ago, I had the opportunity to drive out to beautiful Crestline, California, and meet up with some very knowledgeable microwave enthusiasts, Mike WA6SVT and Gary W6KVC. They're both members of Amateur Television, or the Amateur Television Network. They have a YouTube channel, and they have a huge repeater base here in Southern California where they do amateur television, particularly on the higher frequency bands. And they heard that I had a ICOM 905 and wanted to put it through its paces. So we went up there to do a power test on all the bands, all the way up to 10 gigahertz, to really test if the 905 puts out the power that it claims. We also did a receiver sensitivity test, which I thought was particularly interesting. The importance of all this cannot be understated, because to do this level of testing requires some pretty specialized gear, and at higher frequencies, that gear is pretty expensive and requires a pretty decent knowledge base. So it was really nice to have Mike and Gary show me how it all works. So I'm going to go ahead and pass it on to Mike and let him start the introductions, and I'll be back throughout the video to help out a little bit with what could be some highly technical stuff.
Hello, I'm Mike, amateur station WA6SVT and VP3MC, soon to go to Pitcairn Island with the DX license. What we have here is a test setup for VHF through microwave, and it's also set up to do everything from weak signal through amateur television. Just a very brief info on me. I'm a broadcast TV engineer for KCBS and KCAL Television in Los Angeles. I'm in charge of the transmitters at Mount Wilson, member of the San Bernardino Microwave Society, and also a member of Amateur Television Network. And we also got Gary W6KVC, who's both a member of SBMS and the Amateur TV Network, and he's here helping as well.
Hey, Gary.
Hi, I'm Gary. Longtime friend of Mike. You know, I got to keep him honest. 1963 is when I got my license. Still that little screen.
Yeah, but there you go. We got a video in. Very good. And it should be noted, while I did my best to help with some of the audio, this is a ham shack that is an operational repeater site as well. So there was a couple repeaters behind the camera that I tried to balance out with the microphone using its pattern. But it still got in, so just keep that in mind. Repeaters be repeaters sometimes, and they got a lot of fan noise.
We have a Tektronix NTSC television signal generator, bird watt meter of all the appropriate slugs, Hewlett-Packard 8660C generator for the lower bands and low microwave. And this is a HP 8672A 2 to 18 gigahertz signal generator.
Signal generator, okay.
Yeah, both of these are signal generators.
Okay.
This is a waveform and vector scope for the ATV. And then over on this bench, this is a HP 8594E. And then we also have a Tektronix spectrum analyzer I haven't brought on yet for the higher microwave bands. And then an IFR 1200S, so we can evaluate modulation on sideband AM and FM.
So to kick this off, let me explain the methodologies of the two forms of tests we're doing. The first test is going to be going through each band of the ICOM 905. In this case, we started out at 2 meters and then go all the way up to 10 gigahertz. And we're going to transmit into a test rig of some kind. In this case, we were using a bird watt meter and a microwave power tester. Now, it's explained further in the video, but at certain frequencies, based off of the capabilities of the bird watt meter, it just can't really keep up in comparison to the microwave tester, again, at much higher frequencies. So we did 2 sets of testing, actually, with the bird and then the microwave tester as a sanity test, and we did find that the bird watt meter was actually testing a little bit low. So some of the numbers we had to adjust up to match the microwave tester when we went back through and retested some of the much higher frequencies.
W or FM?
Okay.
We'll probably do C.
And what frequency do you need to be on?
Let's do, what's the weak signal calling? 144.1. 5. You got AM?
AM.
Yeah, you should be
Okay.
2.5 watts. Yep. 1, 2, 3, 4. Yep. 2.5.
Okay.
Okay, next mode.
This is DV. Digital voice. D-star.
9 watts.
9.
I think they might. I'll buy 2 of them. Let you have one.
See, I can still do code.
There you go.
9.2 watts.
All right. Fast forward ahead here and just show you the output for 2 meters and 70 centimeters. We kind of expected it would hit the marks, and it did. Also, this is kind of the departure where most people can do the power output, and we have to start going into much higher frequencies. I'm also going to be kind of fast forwarding a bit through some of the testing. Just know that we tested all the modes of operation on every band, and I will be overlaying the power outputs as we're going along.
There's a little loss. There shouldn't be much in that, fraction of a dB.
Oh, with the coax?
Yeah, I mean,
Yeah.
It should be almost negligible.
Okay.
Not 100% negligible.
Right. So some of this is going to be lost, yeah.
Okay, I'll just leave that slug in. 10 watts.
10 watts. All right.
10 watts of 1200.
Yep.
Yeah. This is upper sideband. Did you already get that one?
Yeah.
That's accurate? Okay. Next is CW, right?
Yep. Yeah, I'll put in their average for sideband. Okay, ready?
Yeah.
We got about 1.7 watts.
AM.
The spec said, 2 watts at
Half a watt on the AM mode. That's about right. It should be 1/4 for the carrier. FM?
Okay, here we go.
1.7. D-star?
All right, here we go. You're going to have to read it. I don't have a good angle on it.
1.7.
All right.
Alright, ATV.
Is it the same frequency?
Go to 24 41.5. 1.65. This is sideband.
Yep. Oh, let me check the power out again. No, that's it.
Okay, I'm going to have to break out the microwave power meter now. 20 dB. Okay, good.
And what are you doing right now?
I got to get the power down, so I'll blow that. I can only put 10 milliwatts into that head.
Oh, okay. So you're attenuating down the signal.
Yes.
So this is a power meter for microwave.
Right.
That's
Yes, I
the
do
idea.
10 gigahertz with this stuff.
Okay. So this is what's going to get us up through 5 to 10 gigahertz.
Yes.
Got it.
Okay, where's your power setting at on there?
On this,
Yeah.
100%.
Okay, are you on the SSB?
Yes, I am.
Okay, let me just lightly talk this. Test.
Oop.
Full scale is 2 watts.
Okay. Okay, so explain the whole thing. So we've got,
Okay.
we're coming out of the 5.
Right, what we're doing
Gigs.
now is because we're in the microwave frequencies, the bird watt meter, my slugs only go up to the 2 gigahertz band.
Okay.
So we have a set of attenuators to get us 23 dB. So I'm measuring 2 watts to give me full scale.
So full scale is 2 watts.
2
on
watts.
this, which is what this is expected to do.
2
or
watts.
around that.
2 watts.
We're expecting to see that around there.
Right.
What?
And this unit here is actually more accurate than the bird. So what we'll do, time permitting, we'll take one of the lower bands and we'll put a set of attenuators and we'll check it, just
Spot
check
check.
because the bird's only accuracy is only guaranteed, I think, to 3 or 5%.
Okay.
Well, this thing's like
Well, that's still
fractional.
pretty good. That's good for most of what
Right.
we do. But this is getting us spot on, particularly on the high
Yeah,
bands. Okay.
it's impressive.
Okay. All right. Let's do it.
Okay, we're on the what sideband again?
Sideband.
WA6SVT testing 5.7.
Ooh. All right. So full scale.
Yeah,
2 watts.
2
on
watts.
5760.
Okay, CW please.
Okay.
I gotta get my little
Here, I'll
Morse
swap
code.
it. Yeah, your key.
Yeah, I like my key, and then
Yeah, that's like
2 watts.
a true ATV user's key is a pair of composites,
It
right?
said CW
Or
with an
RCAs.
RCA jack. You
That's
gotta
right.
Go back.
That's it. That's how you know.
Exactly. All right, AM please.
AM.
And I'm expecting to see half a watt carrier.
Okay.
Let's see. We've got 0.26.
0.26. All right, I'll give you the FM when you're
'cause
ready.
With AM,
I'll let you do it. I'm not going to.
Most people know of AM. Your peak envelope power is 4 times the carrier.
Right.
And we're on FM.
FM. All the way.
Yep.
You want to just do the DV while you're standing there, since it's going to be the same.
Which one?
DV.
Oh yes. Same. Go to ATV.
Okay.
Now go to 5910.
All right. Okay.
More power. It's pegged. It's over.
It's over.
Yeah.
Oh, all right.
Yeah, I can't key.
Giving you something a little
I don't
extra.
want to key too long because
Right, you don't wanna
I'll hurt the barometer.
So giving you something a little extra.
About 2.2 watts, and that could be because I'm sure that in the programming there's certain settings for the drive levels.
Sure.
And since this is a demo model, it hasn't been fully calibrated.
And this is just a dead key carrier signal we're sending out.
Right.
We wouldn't normally be doing that, right?
Well, well, with calibration means that if this goes to the plant and gets highly calibrated, they can set these exactly on. So
gotcha.
This is just because this is just a very basic demo, just to show the operation.
Right.
There's a chance it may not be quote factory calibrated to the fine amount that they would if this was in production.
So now we got to plug this guy in.
Okay.
That's step 2. So I think we maybe pull the bird out and we'll set it on top.
Same thing. Now we got to.
Yeah, but I've got to run the RF cables.
Yeah, just physically get it off there. Okay.
Yeah. So we're gonna need a couple of things, right? We're gonna need
Short SMA.
2.4 megahertz feed off of that.
So you need SMA to SMA cables?
SMA
How
to
many?
SMA.
How many?
So I think you need one for the 10 gigs antenna, one for the 2400 for the transverter.
Yeah, and then you're gonna you got to have one for the reference oscillator, don't you?
No, the reference oscillators, BNC.
Reference 10 meg in. Okay, yeah, we're gonna need that. 24 IF. That's where IF. Oh, it's got 2 connections. IF and antenna.
The second is the one that goes to the 2 gig antenna. So
Well, they've got 2.
Yeah, there's 2.
I know they do.
What's the IF for?
That would be typically for a receiver. But I don't see that.
2.4.
Okay.
But they only got.
Oh, that's right, because this replaces the 2.4 antenna. You got to give it the antenna.
The 2.4 is your IF.
Got it.
But when you're using 2.4, well, not the 10 gig.
So you need to come off the 2400 meg into that. Not that's the external antenna. So you get all band. You don't lose it.
Yes.
You don't lose it.
Yeah, you got it.
You're going to have all 3 antennas.
Yes,
hooked
I
up.
understand.
All you have to do is switch.
That is nice.
Okay?
Yeah, so you don't lose anything.
All right.
We don't want to lose it.
I guarantee you, I've researched.
And I'm off right now.
I've researched as much as I can on this thing.
There you go.
Okay, so
this goes underneath.
There we go.
And then there's we need a BNC to BNC. This is
10 gig antenna, so we're.
Yeah.
So now you're back to that.
All right. Should be ready to rock and roll.
Yeah, let's turn this on too, just to make. I turned it off before we started playing.
Yeah, that's probably a safe.
I wanted
bet.
to make sure we're just
well, that's always a good.
make it sure it comes up. So I've never connected this before, so I'm gonna switch. Did you hear it click?
There you go.
Did it click?
I don't.
Okay.
I heard it click.
I did too. Okay.
This is a ICOM's 10 gigahertz up converter or transverter, and we take following connections. 10 megahertz reference so that you make use of that high stability GPS. And I forgot to mention before, with this little GPS antenna inside the garage, we're locked. It's highly sensitive.
That tiny little nub. Yeah.
Yeah, and we're inside. And this is an outdoor unit. So
and it locked it. Yeah, it locked GPS right up.
So we're feeding the 10 megahertz reference for the TCXO. You take the 2 gigahertz antenna output on this up converter, so you're going to go from the control head as a SDR type system into your RF head, generate 2 gigahertz, and this will convert it to 10.
Mm-hmm.
And then they also provide because if you're going to have this hooked up, you can then, and you want to still operate
So
2
you can still
gigahertz.
do it all.
You don't need to unhook this. You can put your 2 gigahertz antenna here.
Right.
Take the slight loss in the cable, probably not much, and away you go. So we're ready to test.
Okay. All right. So I'll get you back on
SSB.
and what frequency should I be on?
10.368, I think, is the weak signal.
We're just trying to do it as legitimately as possible.
I'm going
as
to
we
talk
can.
slow just to make sure there's
Okay,
nothing.
we're keeping an eye.
1, 2, 3, 4, 5.
So again, it's 2 watts max. I'll check power. Or 100 watts.
Okay, this is designed as a half watt.
Yes.
So
You see it?
So the half watt would be here at that level there.
Okay.
A little bit less. You got about
A little
0.4.
bit less.
And it could be because of this line here, but it shouldn't be that lossy. But that's not too
We
bad.
should see potentially a difference if we do FM too, right?
Right.
Because
Get a little more accurate.
single sideband just with a whistle is probably not
Yeah.
the most.
Well, the thing is,
Lab type test.
what I'm doing is I'm overdriving it
Yeah.
to max it.
Gotcha.
When you're talking, it's a lot
Well,
less.
you could CW key it.
CW.
Yeah.
CW will show us the
yeah.
truth right now.
Because in weak signal on 10 gigs, we use CW every once in a while to make contacts.
Do you?
Yeah, besides sideband or,
Mm-hmm.
Okay.
all modes.
Next mode, please.
Your key, sir.
My key. Alrighty. Yeah, I'm sure the engineers back at ICOM would
They're loving this.
they'll fall off their chairs. Ready?
Yeah.
Yep. There, that is. This is all in dBs. It's not watts.
Oh, okay.
So that's about 0.4 watts.
And again, because of the frequencies we're playing with, we could be getting some amount of loss.
That, and again, the calibrations. I don't know how the factory's calibrated
Right.
it.
There's FM.
All right. Same thing.
Okay, pretty much solid.
Yeah. We're doing
Yeah.
the
So
carrier.
here's your DV, right?
Okay. Same thing.
Okay. And
ATV.
ATV, what frequency?
10.4 gigahertz, please.
Okay. So you're
it's
putting out.
it's a little over 2 watts.
Okay.
Yeah, it's pegged it out pretty good. Let me find one more attenuator pad and see what I've got here. What that will do is I should be down 10 dB lower, which
Okay.
I'll just have to drop the scale down, and then I'll be able to see what it actually is.
Oh, you pegged it again.
Just a little more. Okay, we're just a hair over 2 watts. So
pretty close to what we were saying, or no?
Okay, I'm going to change these. Even though I did the bird, let's go through the modes. Flip over to SSB, please.
Okay.
At least on the microwave, because most of the people are going to want this for microwave.
Yeah.
Same thing. Okay.
So the bird
next
was
mode.
a little low.
Yeah. It should be noted that what we typically call a microwave power meter is by thermal heating, and it's a true watt meter. A bird watt meter is nothing more than a volt. It's measuring R of voltage on a 50 ohm circuit. So that's one of the reasons the accuracy is not quite as good. Next is receiver sensitivity.
How do we do receiver sensitivity?
Well, we're going to first go to 10 gigahertz and work our way down.
Oh, okay.
Yeah, because we got all this other stuff hooked up still.
Okay.
Okay, go ahead and set up to 10.368, please. All right, so let's tune a little bit, see if we can pick up a carrier. I think we're...
Oh, there she is. That's unmistakable.
Yeah.
And now you slid down, so if you go back up to 368, yeah, we're watching it. Look at that.
Isn't that lovely?
Look at that.
That is cool. Hey, it's worth the price just to have that, man. That is...
And you're right. You just on it. Yep, 168. And I'll zoom in here. You're right on it. All right, here we go.
Yeah.
Right on it.
Yep. Now, let's get the sets. We're at minus 50, 60, 70, 80, 90, minus 100, 110. And I'm going to have to add some attenuator pads, folks. It's doing pretty good. So let's put a 20 dB pad in. So we're at minus 110. That'll be 130. That'll be about as good as you're going to get.
He's adding attenuations to the point that we can't hear it anymore, receiving the signal. So he's at negative 110 dB right now, trying to dBm.
Yeah, which is pretty sensitive. That's
it's got to go on the 10K, right?
Yeah.
Okay.
Yeah, I mean,
I was thinking about that. I was thinking to myself, where does it go? Yeah.
Yeah, I'm attenuating the signal generator.
Yeah.
As well as we probably got a dB, half a dB to dB loss in that cable coming up from the generator too.
Yeah. It's still there. I can still hear it.
Yeah, go ahead and turn the volume up. Now we're at minus 130. Typically minus 132 dBm is what you can hear. And with the 1 dB loss, this thing does have excellent sensitivity. Now I can do a minor with the actual power. So we're minus 130, 31, 32, 33, 34, 35, 36.
I still hear it.
Minus 137 dBm. That thing is one hot receiver.
That's pretty good.
You're going to be at full sensitivity.
Wow. That's pretty good.
Impressive. Next band, everybody.
Josh back again. Many data points on the sensitivity test that I just thought I'd kind of cram into one little spot. So the best performing modes for sensitivity across all the bands of operation is going to be single sideband and CW. CW in particular was negative 38 dBm was possible at the sensitivity test, with SSB right behind it at negative 137. FM and AM modes were negative 130 dBm on all bands except for 2 meters. And there's a speculation that that's possibly because of 2 meters being a noisier band, but we don't know. Also, again, I will say this is not necessarily final production, or we'll call it a demo unit that may not go through the final production calibration that some 905s or all of the retail 905s will get. And amateur television was negative 90 dBm, which is exactly the spec that was requested from Mike and the other people who had some input to ICOM, but they probably know that's pretty much the standard at which they run for amateur television. All in all, from Mike and Gary's point of view, this is incredibly good numbers, and they were very impressed by that. So, awesome.
138. Got a 1 dB improvement.
Are you going to feed it?
Now, there's no subcarrier, so I've got to look up the... And then was this anything about what filter's on there? Or I guess it's just the filter?
It's wide open. Well,
you can't change it. It's whatever filter they're using for.
No, you can change it. If you hold down filter, you can change it to whatever you want. What do you want the bandwidth to be?
What is it now?
17.
That's where you want to be.
Okay, 17 it is.
Excellent. I didn't even know they had the selectable bandwidth on the
all of the ICOMs do that.
Nice.
That's the standard filter.
This is one hell of a nice radio, you know that. Does this have display for TV monitor?
Yeah.
Okay, go ahead for that. I don't know if it'll show snow or not.
That's it. Yeah, it's snowing right there. Right there.
Okay, there we go. That go to full screen?
Yeah. Ready?
Yes, full screen. So you can look at that for quieting. That's what you need for P5. Okay, minus 70. That's minus 90. That's perfect. That's where you start picking up the signal. They probably got another prototype in Japan, I would suspect. But
this is it.
This there's no more. This is the one and only prototype.
This is my understanding. Is I got it.
Well, this.
I'm definitely the only one in the U.S. that has this, and it may be. I don't know. I don't know where else it's been.
We got to touch it first.
You've touched it. Yeah, you're one of the few.
Gary, get the rope, tie him up.
Yeah.
A guy named Senior Sales Manager, and his name happens to be Novak.
I know.
He'll
He
be
probably,
on my phone in 5 minutes. Where in the hell are you and where's my equipment?
Yeah.
yeah, I did.
So he's adjusting attenuation
Yeah.
to see where the snow comes up,
Yeah,
right?
that's a point of detection, -90.
Point of detection is -90, which this is doing.
All right, and then for full quality, for a snow-free picture, -80.
Minus
It's excellent. Yeah, this is good, about as good as you get.
Great.
They did their homework.
All right, so Mike, we've been playing around for a while now. What do you think so far?
There's one hot little rig you got there.
Yeah.
Yeah, ICOM's done their homework. Since this is just the first demo, and it probably came out after we gave them the video specifications, video modulation just a tad bit low, and the pre-emphasis, or there's a little bit of roll off in the video bandwidth, but not bad. And then the sound carrier is not on the ATV standard sound carrier. Now, if it is possible to make that frequency adjustable on the subcarrier, that would be even better, because there's a couple areas of the country, especially on the 1200 megahertz band, where they're using a 5.5 megahertz instead of a 6 megahertz subcarrier.
And you're talking about where the audio...
The carrier that
the carrier
audio.
for the audio, right? Because
Right.
right now, even though you're transmitting the color bars, we're not picking up the carrier.
We're not picking up the sound carrier.
Okay, all right.
It is there,
Mhm.
but it's just not
Oh,
on
gotcha.
frequency it's tuned to.
Well,
But it's very impressive. This thing is hot as a pistol on all three of the microwave bands. Full minus 137 for sideband, and for the most part CW is a dB or two better with the narrow filter clicked in. AM and FM are down, and this is just the point where you hear the tone. It's not the 20 dB quieting or 12 dB
Right.
cyanide, but at the point you can hear the tone enough you could actually start hearing voices is about minus 130, and that's pretty much across the band. And the only thing that I noticed is that the 2-meter band sensitivity is about 3, maybe 4, somewhere between 2 to 4 dB less sensitive than the higher frequency bands, which may not be a bad deal because there's the higher noise level on 2 meters. But for what you get in, what's impressive, this thing locks a GPS inside a building. Which
yeah.
Yeah.
With the little nub antenna there. Did just fine.
Right, and this doesn't get too hot, just about the right temperature when you're transmitting. So
It's warm enough for up here. It'll melt the snow for you.
I don't even know if it's that warm, but anyway, it shouldn't have to worry about the unit overheating.
Yeah.
On some of the testing we did when we used the Bird watt meter, some of the readings were a little low. When we did use the microwave power meter, which is the really accurate way, it was right on the money. So all the bands, the power met specification, if not exceeding it by about 2 or 3%. So
Excellent.
well,
Well,
come up with a winner.
yeah. Thank you for taking the time today.
Sure, not a
And
problem.
you too, Gary. Gary's off camera, but thank you, Gary. We had a lot of fun working on all this for testing. We'll be doing some more, and obviously check it out when you go to When you go to Hamvention, it'll be this model that we were playing around with. So, all right. So that concludes my time with my borrowed 905. A big thank you to ICOM for making this happen, particularly Ray Novak. Appreciate you, man. And if you want to go watch any of my other videos, like the live stream we did, going through the modes of operation and demonstrating some of the capabilities of the radio, I will link those in the description and the cards. So go check those out. If you found this video helpful, insightful, or just fun, go ahead and give me a thumbs up. And if you have not, click subscribe. I would appreciate it. I'm Josh KI6NAZ. Thanks so much for watching. 73.